All right, so I just wanted to go over this really quickly. I just checked out some LLM reasoning benchmark stuff, and I found this website over here, which gives me some interesting questions, assisted and unassisted. So I use the unassisted question number 13, for instance, here, and it tells you like the correct answer first. Answer is D. This is a trick question. According to Brooks' law, software development projects have tasks that can't be easily parallelized. There's also a lot of communication overhead and factors at play. All right, so what am I doing? I'm trying to recreate, using PromptOwl, the whole way to go through the thinking process for thought traces for creating synthetic data for training large concept models. So the idea here is that I have an identity script. I gave it a little bit of a down-to-earth personality because I realized that made it like less lofty. And also I'm getting these results on using Mistral Mixtral 8x7b instruct. And this got the answer correct on question number 13, while the rest of the things, including O1 preview, did not get the answer correct. Everyone said it was 40 developers, and these are large models, while I'm using a 7B MOE model. So let's just go over here and take a look at it. I mean, it's a pretty simple setup. In my test script, I have just a couple of things set up. One was Quen, because I've been checking that one out. And then I just have a main function, which gives it a prompt, and I could choose a model optionally. So I just have those chosen down here. I have a list of prompts, and then I just call that function in PromptOwl, and I basically an async function, and then I run that through my prowl stack. And first I'm doing identity, input, and then think. And this is all passing its completions to each other, and then the only input is like user request. So the user request just becomes the prompt, and then so it goes through identity first. It says I'm an advanced thinking AI language model with a down-to-earth personality, and I give it some interesting stuff that I found. I've sort of tweaked based off of going through the sets of this data over here. So. All right, what are we doing here? So what we have then is we have it doing an output, which just gives us a longer setup here, and we're passing the prefix into the output. Let me just close these out. All right, yeah, we don't need requirements because it only requires PromptOwl. I'll be sharing this all this code, probably in the description below. And so over here we've got this whole thing set up so that, yeah, okay, that's correct. Okay, so over here we've got this all set up. Oh, I was actually going to do early stopping here to try and do some sort of a early stopping thing, but I think I'm going to take that part out. I'll just take that off the stack. Silent is default to false, but I was running it on true here for a little while. So basically what happens when I run this script when I run this this set of prompts in that stack order, and I'm just going to run the first prompt, right? And the correct answer again is D. This is a trick question. Assume there's a software development project. We've calculated that it takes 100 days to complete the project if there are 10 developers working with the project full time. We want to complete the project in 25 days. How many developers we need to achieve that? 10, 40, 100, or this is a trick question. And the reason why it is a trick question is because, yeah, there are projects that have tasks that can't be easily parallelized, so no matter how many developers you use, you're not going to get to that sort of you're not going to, it doesn't matter how many developers you use, you can't parallelize some of those things, meaning that, you know, one thing requires another thing to happen first. So even if you have 5 people working on each of those things or something like that, they still have to wait for the 5 people before them. So even if it's just one person working on all of it, it might take the same amount of time, and it has nothing to do with completing the project. Like, the amount of developers has nothing to do with completing the project in 25 days or any amount of time. So I ran it before, and just so that I don't generate different output real quick. Because I am running this, by the way, I'm using on the Think, I'm actually using some pretty high temperatures to try to coax it into generating an answer inside, like, that properly fits within the format without getting filtered out or having to try again. Plus, it gives it a little bit to work with, and then I keep it low throughout, and then on the final conclusion, I make it like a little bit larger, because there's actually less that could actually fit there, right? But it's not a super high temperature, so it's not going to go off the rails. All right, so then we'll leave stop early out and everything like that, right? So this is what we get back. What I'm doing here is I'm just turning the thoughts. You might notice here that these are the same variable that's output each time, that's being generated each time. So it actually has an effect where it goes in the history of the values of the history. So I'm just joining that by those values, and then you're getting like this nice little output down here for the thought. The first thing to note is that the problem statement, so it goes through the thoughts basically. And again, this is a 7B model. This is answering a question that these larger models without some sort of a thinking process can not really answer correctly. We could pop a couple of other ones in here. This one is super easy. This one, like, even any of these, I think, could get it right. The first, number 1. Number 2, grocery store wanted lower costs. So this one is, the answer to this one is B, close to 20% idleness. So let's just change the prompt to 3, or no, 2. 0, 1, 2, 2. Okay. All right. So if we run that, got some debug output, but let's just make this a little bit bigger. And yeah, based on the information provided, grocery store would see close to 20% idleness after firing 40% of their cashiers. However, it's important to consider the potential impact of customer service and overall sales before making any decisions. So it does make some interesting things here. And what I've noticed is that it makes some interesting points in its final answer. That final answer is correct. And yeah, it does some interesting stuff here. And you might notice here in the identity, I tell it, I will use known statistical likelihood and probability to help solve the problems. Logic and mathematics where necessary. I will think outside the box. I will reason with critical thought and attention to detail. So these are all sort of like system prompt idea, basically, not necessarily system prompt, what people in chat prompting would call system prompt, but this is like the identity block, so to speak. And then we have the input block, which is just that, and then we have the thought block. And then it's like, I think something, and then alternatively something else. So it forces it to switch to a different alternative thought path. And then it goes, however, right, which is like a but, which is like, so okay, it has this alternative, but here's the second guess, right? And then what's more is that this, that, and that, based off of that, what I just said after the second guess. And PromptL sort of just makes this so that it's nice and formatted. It cuts it off after it tries to like make multiple lines. So this all ends up just working out so that by the time it gets to therefore, the final conclusion, it's pretty much decided on what it's going to do based off of the alternatives that it's looked at. Okay? And I've included this inside of the think tags in my formatting here. This is just because this is the same format that training sets use. So So basically, when you get the final completion of this, which I'm not outputting, in fact, I can just output the completion of this. There we go, print our completion. So we can just see, as the bird flies, how the prompt was filled out by the LLM. Okay, so yeah, the reply obviously doesn't have a thing here, but it's told to stop at /reply, and this is just because it's already programmed sort of to think inside of these tags like I've set it up before, right? So now the reply is going to be that. And what I'm doing is I'm forcing each of these to be one line only, and I even tell it in its thinking instructions. So you can see all of this gets blobbed together basically. You have your identity part, and then the user request part, and then you think it out, write your thoughts on the above. Each thought should be one paragraph, and then it just does that, right? Close to 20% idleness. The reason, so this is what the thoughts that would show up basically, and then you have the reply output, and it gets it right again, right? Even though there's some stochasticity there in the very beginning. This stochasticity goes through a bottleneck, so the temperature goes through a bottleneck basically where it forces it down into more logical thinking, because and it forces it down into listening more to, so like the first thought is basically sort of almost flowery, it's almost random, almost, right? It's very raw, so to speak. It's at 0.5 temperature, that's pretty high. If you get up to like 0.8 on some of these models, you're getting into the territory of like just blabber, right? And then you have the alternatively, which goes down, brings it down to 5% instead of 50% temperature. So that will make it so that it's just now, it's now thinking inside of like a very specific and less random state, and it does that for 2 or 3. It does that for 3 of those, and then on this one it's allowed to like be a little bit more random. But since it's already conditioned by all that stuff, the randomness is going to come out of here is going to be still statistically within 30% of alignment of everything else here. So that's what conditioning does for us in these types of prompts, and writing it out like this really helps me personally to see how these go together. Anyway, so that's how that's all set up, and that's how you get these types of results. And then essentially all I would have to do here is just make it so that it's getting this information, right? It's got the user request, right? It's got the that's come back. It's got the thoughts, which are all set up in line, and then it has the response. So then I can just take this and I can run a whole bunch of different prompts. I can run through all of these different prompts and have it all saved to a CSV file using pandas, and then that would be my synthetic training data set. So that's the whole idea here is making a synthetic training data set for creating a thought-based model, a large concept model, and that's that. See you next time. Please like and subscribe.